All right, we got a function defined by, you see the figure above shows a graph of the piecewise linear function f for negative 4 to 12. The function g is defined by this integral from 2 to x. So we're starting, everything starts at 2. A, does g have a relative min, a relative max, or neither at x equals 10, and justify your answer? So our first statement when we did this, and it is now, is that g prime of x is equal to f of x. And we're given information about f, so we need to connect what we're given to what we're being asked about. And we're being asked about g. So at 10, it's asking, is there a min, a max, or neither? Well, there's neither. So neither. Because f of x does not change sign at x equal 10. And you can put it down in the white spot if you want to. I'm trying to keep the graph on the screen. B, does a graph of g have a point of inflection at x equal 4? And we're going to justify the answer. So we're up at here. Yes. F of x changes from increasing to decreasing. So if the f is the first derivative, the fact that it's changing from increasing to decreasing means that the second derivative of g is changing signs. So g does have a point of inflection there. C, find the absolute minimum value and the absolute maximum value of g on the interval negative 4 to 12. So let's go with, let's find g of negative 4. So it's letter C. G of, let's see, there's a critical point at negative 2. That's where f would be 0, which means g prime would be 0. Over there at 6, so g of 6 and g of 12. We could probably rule one of those out. Negative 2 is probably ruled out because the first derivative is going from no. 6 would be ruled out because that would be a local maximum. However, the rubric has 6 evaluated, so we better test all the critical points. All right, so we're going from 2 to negative 4, and it's the integral. So we're looking at area. So this area right here cancels out that area right there. So all we got to really do is find that area. Now, if you found all 3 or the big triangle and subtract out the little one, that's fine. But I can kind of use symmetry here to reduce the amount of work we need to do. So this is going to be negative 1/2 times 1 times 4. And it's negative because we're integrating from right to left over area that's above the x-axis. So it's going to have a negative value. Negative 2. Negative 2. What am I doing wrong? Oh, from here to here is 2, not 1. I knew it was negative 4 because it's the third time I've done this today. I didn't make that mistake earlier. Negative 2. So now we do have to include all this. There's not going to be any canceling out. So we have negative 1/2 times 4 times 4, which is negative 8. Then the next one is over there at 6. And we're starting at 2. We're going over to 6. So that's going to be 1/2 times 4 times 4. That's 8. And then finally all the way over to 12. Well, this area is going to cancel out that area, so I'm not going to worry about those areas. If I felt like they were different, then I would calculate them. So at the very end, 10 to 12 is 2. 1/2 times 2 times negative 4, because it's going down to negative 4. So this is also, let's see, negative 8, negative 4. So absolute, did they call it absolute? Yeah, they did call it absolute max of 8 at x equals 6, and an absolute minimum of negative 8 at x equal negative 2. For negative 4 to 12, find all intervals for which g of x is less than or equal to 0. So find out where g is negative. So letter D. If we go back from from 2 to 0, that's going to be a negative value. So we'll have negative there. And then when we keep going back to negative 2, that'll be more negative. So this creates, this very negative value. And then this piece will be positive, but it only cancels out this piece. So it's a big negative, and then you don't go back the other way to get to be positive ever. So we're looking at negative 4 to 2. Now it says equal to 0, and g is 0 at 2 because you're integrating from 2 to 2. That's 0. So we'll include negative 4, it'll be negative there, and it'll be 0 at 2, we'll include that. So now we get to the other side. And we get this much right here, that'll be all positive. That'll stay positive until it gets back to 0 right here, because the areas will cancel out. And then from 10 to 12, now we're adding on negative area. So 10 to 12. And we're going to include 10 because it gets back to 0 there. It says equal to. It says equal to. If it didn't say equal to, we wouldn't include 2 and we wouldn't include 10. All right, any questions on that little piece? 1 for making this statement right here somewhere in A, B, C, or D. You got to state it somewhere. So they would let you state it all the way at the very end, which is a little odd since you would have to use it beforehand, but that's the way they have it. 1, answer with justification, pretty straightforward there. Considers negative 2 and 6. So if we would have said, realistically, we could have said that 6 is not going to be a possibility because it's a local maximum. You still would have lost that point. They expect you to check the critical values. Considers negative 4 and 12. Got to check the endpoints. Answer with justification. And finally, you get 2 points, 1 here for the intervals. Pretty straightforward there. The function f is defined on the closed interval negative 5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g be the function defined by negative 3 to x. So they want g of 3, negative 3 to 3 of f of t dt. Negative 3. Now we're starting at negative 3. And we're going all the way over to 3. So we got a triangle. 1/2 times 1, 2, 3, 4, 5 times 4 minus 1/2 times here to here is 1. We're going to 3. But now I got to know what value that is right there. So we got to figure out, is it actually at negative 2 or is it something else? Well, if we look at the slope, we go down 1, 2, 3, 4, 5, 6, 7, 8, and over 4. So down 8 and over 4, the slope is negative 2. So if we go down 2, we need to go over 1. So we figured out that it's actually negative 2. Now I already minused it, so I'll make that 2. I already took care of the negative part. So 20 divided by 2 is 10, minus 1, the value is 9. On what open intervals contained in negative 5 to 4 is the graph of g both increasing and concave down? Give a reason for your answer. Well, g prime of x is equal to f of x, if you take the derivative. So g is increasing when its derivative is positive. And g is concave down when the f prime, or when f is decreasing. So when f is decreasing, it's concave down. When f is positive, the function is increasing. So I want a positive f that's decreasing. So that's right here. There's a positive f, but it's decreasing. And it's an open interval, negative 5 to 4. So negative 5 to negative 3, union with, and there's one more spot where f is positive, which means g is increasing, and f is decreasing, which means g is concave down. So that's going to be 0 to 2. How do I know that? Since I made the connection, I can talk about f. F is positive and decreasing. The function h is defined by that. Find h prime of 3. So now I need a little more room now. Letter C. H prime of x is bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So 25x squared. And we're evaluating when at x is 3. So we have 15. G prime of 3 is the same as f of 3. And we decided that that was negative 2. We used the slope to decide that. So that's negative, what did I say, 2, yeah. G of 3, we found that. We did that in A. So we don't have to redo that. That's 9. Times 5 over 25 times 9. Well, now it's all a little bit of arithmetic. I mean, I'm tempted to take 25 times 9, but I kind of looked ahead a little bit and noticed that that's going to reduce. So negative 3 over 9, negative 1/3. So 75 over 25, that ends up being 3. So I don't know, if you can look ahead a little bit, that might save you a little bit of work when you're doing all this arithmetic. Which usually there's not a whole lot anyway. Let's see, D. The function p is defined by that function. Find the slope of the line tangent to the graph of p at the point where x is equal to negative 1. So slope of tangent line. So f prime of x squared minus x times 2x minus 1. So a chain rule. Take the derivative of the outside, leave the inside alone, multiply times the derivative of the inside. What's that going to be? 1 plus 1, 2, times negative 2 minus 1, negative 3. So I need f prime of 2. But we kind of already talked about that, how the slope from 0 all the way to 4 is negative 2. So the slope at, the slope at 2 is negative 2. And that's what we want, the derivative. Negative 2 times negative 3, 6. Let's look at what we might see on, well, here's a rubric. One for the answer and reason. H prime of x, that's 2 points, getting the derivative and the answer, negative 1/3. 2 for the derivative, probably 1 here and 1 there. And then, of course, answer for 6. So very straightforward rubric on this one. Here's multiple choice. Implicit differentiation. Find dy dx. So we have 2y dy dx minus first times the derivative of the second plus the second times the derivative of the first. And that's equal to 0. Make sure you take the derivative of everything. I think it'd be pretty easy to leave that as an 8. Let's factor out a dy dx. 2y minus 2x squared. And then this will be negative when you run the negative through, and then we can add that over. So that's equal to 4xy. So dy dx is equal to 4xy over 2y minus 2x squared. You can factor a 2 out of the bottom, divide it, and you get 2xy over y minus x squared. So it's like we just reduce everything by 2, by a factor of 2. And that ends up being letter B. So implicit differentiation. Here's integral. The first thing I try to think of or try to see is it U substitution. I think that's the easiest, most direct way to integrate. We look for partial fractions, integration by parts, maybe a couple other things. Looking for that inverse tangent one. Or here's one that you might see where it's x to the 5th plus x to the 3rd over x squared or some version of that. Whenever I see a single term in the denominator, this one would be very easy if you see this right there, that you can divide them. Like you use common denominator. So that's a technique that you probably need to look for as well. This one happens to be u substitution. So I see a function and its derivative, at least a multiple of its derivative. Oops, squared. Now we don't have 3x squared dx. We only have x squared dx, but that's all right. We'll just move the 3 over. So 1/3 du is equal to x squared dx. So you have to be able to see a function and its derivative for u substitution. So 1/3 integral x squared dx becomes du. So we have u to the 6th du. 1/3 times 1/7 u to the 7th plus c. So we're looking at 1/21 x to the 3rd plus 5 to the 7th plus c. So u substitution. You guys are getting pretty good at this. This is pretty straightforward. Riemann sums, but I thought, well, let's look at it one more time. Value of a continuous function f for selected values of x are given in the table above. What is the value of the left Riemann sum approximation using the subintervals? And they show you the subintervals. Well, we have 3 subintervals, 1, 2, and 3. Now 0 to 25 is 25. But then the height is either going to be 4 or 6. And of course, we're using left Riemann sum, so we're going to pick the 4. And then 25 to 30 is 5, and we're picking the 6 now. That's the left side of 25 to 30. And then 30 to 50 is 20, and the left side is 8. So 100 plus 30 plus 160, I'm getting 290. Everybody awake? I know it's very exciting. Very, very exciting. Stay focused now. You're doing a good job. Here we go. Which of the following gives the length of the curve y equals square root of x over the closed interval? I want to talk about length because some of the stuff we just don't use very often. I mean, how many times have you taken the derivative of x squared? I mean, 1,000,000 times feels like, right? Well, we haven't done length very often. So length of a curve is a to b of square root of 1 plus dy dx squared. It's a Pythagorean theorem. It's little tiny right triangles working our way from the beginning to the end. And we want an infinite amount of triangles that are infinitely small. That's integral. So we need dy dx. That's 1/2 square root of x. Or you consider it x to the 1/2, that's 1/2 x to the negative 1/2. There's the derivative. But then when we put this into the integral from 1 to 4, we're going to square that. So 1 plus 1/4x dx. So there's the derivative squared. And they do a nasty trick. They have an answer where it's not squared. That's not it, of course. Where is it? Right here? Is that it? So if you forget to square the derivative, they have that for you. The only other one I would put as a distractor is maybe I'd do, I don't know, 1 plus square root of x. I don't know, something like that. That'd probably be a good distractor if you don't take the derivative at all. But they don't have that. Here we go. If f of x is x squared minus 4 and g is a differentiable function of x, what is the derivative of f of g of x? Well, that's f prime of g of x times g prime of x. So we do the chain rule. That's the definition of the chain rule right there. Take the derivative of the outside, leave the inside alone, multiply times the derivative of the inside. Now, this is the other piece of information that they give us. So we know that f prime of x is 2x. But we're going to plug g of x into that. That's what that says, f prime of g of x. So we can do this. We go 2 times g of x. But then this just has to tag along. And that's the most we can do because we have no information on what g actually is. We know f, we don't know g. That's as far as we can take it. We haven't seen vectors for a while now. A particle moves in the xy plane with position given by. So they give us the position vector at time t. In which direction is the particle moving as it passes through the point 3, -2? So we want velocity is equal to the vector -2, 2t. And that velocity vector is going to tell us which direction it's going. But what's t? They don't give us t. What's that? Not necessarily. Most of the time, yeah. But what I need a number. You don't have the number? Okay. But you're pretty sure it's going to be positive. Yep. It is actually, I believe. Yeah, it is positive.
You set the y part of the position function equal to -2.
Very good. So this is an x and a y, and this is actually an x and a y. So the y's, if we're talking about the same spot, they better match each other. So t squared minus 3 is equal to -2. So t squared is equal to 1. T is equal to plus or minus 1. Uh-oh. It's not both. So what could we do now? What's that? Which one is it? Do the x. Yeah, there you go. 5 minus 2t is equal to 3. -2t is equal to -2. So it's actually 1 that we're looking at. So now this evaluated when t equals 1 is -2, 2. So this is the x, that's the y. So left and up. Up and to the left. There you go. Very good. Very good.